Good evening, morning, afternoon, and whatever time of day you guys are watching this, and welcome back to the TheQCEGuy. And today I just thought I'd be showing you a brief rundown of a few key concepts with our favorite subject. Not really, but why not? Chemistry. So we're going to be talking about some chemistry stuff today. In particular, I'm thinking that it's not really well covered, but if you weren't here for Unit 1 or you just want a quick refresher, I'm going to go through like balanced equations and basically like how you should like work them out. So you're going to have like worded questions where you're going to be like sodium nitrate reacts with potassium chloride, what forms, la 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 la. So from that we're going to have balanced equations. We're going to have a quick look at ionic equations that form off these balanced equations, and that's basically just the net ions that react, so what is and what is not reacting inside of the reaction. And then finally, the last thing I'm thinking of covering will be a quick little rule about solubility. So in class, for anyone watching, for at least QCE's Unit 1, Unit 2, sorry, QCE's Unit 2, solubility in aqueous solutions is quite a key part. And an aqueous solution is basically any solution that chemical is mixed with water and will form some form of like a mixture. Anyways, there's a few rules with solubility here that are really good to use if you're trying to identify if a reaction is going to form a precipitate or if it's going to form like an aqueous mix. So I'm thinking, without further ado, let's get into it. So let's start with our balanced equations. Okay, what I want someone to imagine is you need to break up the words into like each part, and from that point you can probably evaluate like what to do. So for example, let's go a piece of magnesium metal reacts with what's something I can do? Hydrochloric acid. Okay, determine the balanced EQ. So what's going to happen here, right, is I first want to think about like what the question's asking me. Okay, so I need to determine this balanced equation. Okay, this is like what I'm trying to do, this part. Okay, so that's cool. What information are we given? We're given that it's a piece of magnesium and it's reacting with HCl. So the first thing to think is anything that's a metal will just be bonded like to nothing. So that magnesium is going to be by itself, and a piece of magnesium metal which will be a solid. Okay, because it's like, imagine a strip of magnesium, like a little bit of magnesium foil if it was to exist, or a little strip. So that's what we're running with, magnesium. Okay, and we're going to be reacting it with HCl. Well, that's easy. It will be hydrochloric acid in a word question, but we know HCl or hydrochloric acid to be that. And the nifty part of that is HCl or anything that basically is going to be reacting is going to be an aqueous solution. So you can chuck an AQ here. And then the next part of the reaction that we need to determine is like what's going to happen at the end. So the reaction of a metal and an acid, I believe, forms a salt, and it forms hydrogen gas. So what's going to happen is that Mg is going to stay here, that Cl is going to come over, and then you're going to have MgCl. That's not balanced though. I'll get to that in a second. And you're going to have H2, okay, because that's our gas. H2 we can write as a gas, and MgCl we can assume is going to be the aqueous. I'll talk about how we got to that being aqueous in a minute, but yeah, so we're going to say that's aqueous for now. And the last thing we need to check is Mg. Okay, Mg is a 2 plus, Cl is a 1 minus. Okay, so to balance it out, we're going to need Cl2. So Cl2, and we've got H2, but see here how we've only got 1 H and 1 Cl, but we've got 2 Cl and 2 H's over here. We're simply going to add a 2 in front of that. And there we go, that's balanced. But the main idea of it is you just pull the words from it, and then you have to try and write the equation. So another example might be, let's go potassium iodide reacting with sodium nitrate. Let's go lead nitrate. So the cool part about this, right, is we find out, okay, this is reacting with that. So something plus something, or potassium iodide plus lead 2 nitrate. And now we need to determine what potassium iodide is. So potassium is K, and iodide is I. The charge of potassium is a K plus. So that's a horrible K. That's a K plus, and the charge of an iodine is I minus. So these are going to balance out. So the full formula for potassium iodide is Ki. Cool. Lead nitrate. Okay, well lead, and then this bracket here, this II, means that the lead is of a 2 plus charge. So it's like Pb 2 plus. Okay, cool. And nitrate we know is NO3 minus. So we're now going to run with that, and we can determine lead nitrate to be Pb NO3 2. And the way we can get this is, it's called a cross method if you want to try it, where you bring that number down, and same over here, but that's going to be in a whole bracket. So this number is now going to come down to here. So lead's going to keep 1, nitrate's going to get 2. Cool. We now have our two things, okay? And we can write the first part of our equation. Potassium iodide in an aqueous solution plus lead nitrate NO3 2. And now the next part of the reaction we're going to consider is basically a double displacement, where these are just going to swap positions with each other, okay? So K has a charge of +1 from up here, our K plus, and our NO3 is a minus, okay? So it's going to form KNO3, and it's also going to form some amount of lead iodide, okay? And our lead we said was a 2 plus, okay? Because it's like lead 2. So Pb, and iodine's a -1, so it's going to be PbI2. Okay, now looking at this, right, we've got 2 nitrates and we've got 2 iodides, okay? But here, these nitrates are, oh sorry, we've got 1 potassium but 2 iodines, right? And this iodine here, we want to keep, so we're going to double that, right, to get our 2 I2. So I2, I2, right? But in doing so, we're also going to have 2 Ks, right? But the neat part about this is because this lead nitrate is NO3 it's going to need 2 nitrates, and so we're going to chuck a 2 in front of this. So now we've got K2, K2, NO3 well, 2 groups of NO3 as well, lead, lead, and then iodine times 2, iodine times 2. Cool. So now we have a fully balanced equation, and the last bit that we need to do, I don't know what happened to my menus, but the last bit we need to do is essentially that is going to be aqueous, the PbNO3 and then the nitrate will be soluble, and the lead iodide will be that lead iodide will be the precipitate. Okay, sorry about that. And our whiteboard program just decided to shut down, which is just awesome. So instead I'll be using this instead, but I'll still get to the point. So the next part that we want to cover was going to be the ionic equations. So ionic equations are pretty straightforward. Let's get a hypothetical from, let's just get any hypothetical, right? Let's go magnesium plus H2SO4 or sulfuric acid. That is an S, just horrible at drawing. Mg plus H2SO4 is gonna break off and yield MgSO4 SO4 plus H2. So we're first gonna write like what state. So magnesium is gonna be that solid piece of metal. The acid is going to always be aqueous. Magnesium sulfate. We're going to assume that it is aqueous. It probably isn't, but we are going to just assume it because why not? And obviously H2 is the gas, right? So what we can say is that in this reaction, right, the ions involved, well, magnesium is a solid, okay, cool, and it's getting transformed into an aqueous, okay. So this reaction, how it's getting transferred from a solid to an aqueous, okay, magnesium is definitely involved in a reaction. How H2 removes itself from the reaction, it goes from the aqueous to the gas, is also interesting. However, the sulfate, how it's remaining aqueous in both, isn't interesting. So the full ionic equation that we can write would be Mg, and now in this case you chuck on your charge of your ion. So magnesium's a 2+ in the rare earth metals group, and it's a solid, and then we're going to be reacting 2 hydrogen ions, 2 H+ ions, right? These are going to be aqueous, and we're also reacting a sulfate ion, an SO4, which I think is a 2-, and that is also aqueous because of the that solution of sulfuric acid. That is going to be yielding, or that's going to result in magnesium 2+ in an aqueous form, plus a sulfate in an aqueous form. Make sure you include the charge. The charge in this case is a 2-, and you're going to have some H2. Actually, don't do that. We'll go 2H+, and this is going to be in the gaseous form. So these are all our ions involved in a reaction. And the final thing that you do to get your proper ionic reaction is look for anything that stays the same. So magnesium solid to magnesium aqueous, that changes, so we can keep that in. 2H is going from aqueous to a gas, so we're going to keep that in. But sulfate 2- is aqueous, sulfate 2- aqueous. So we don't need to include our sulfate. So our ionic equation now would just be Mg2+ plus 2H yields Mg2+ plus 2H, but obviously change the states. And there you go, that's how you do the ionic equations. The last bit that I wanted to talk about that's also quite important to understand is the idea of solubility. Solubility is quite a straightforward process once you understand a few key acronyms. In this case, we only need to know one, but it's going to help a lot. And the main idea of it is you'll have a question, it'll be like, get the balance reaction, get the net ionic, which is what we did, like only the ions that react, and then determine which reaction is going to form the precipitate, or which reaction is going to form the solid. So this rule that I'm about to show you is pretty easy to remember, and it's for everything that is soluble, okay? Which means that it's going to become a liquid or it's going to get absorbed into it. It's not going to form a solid, okay? So soluble, okay, that means it's gonna form a liquid style thing. Insoluble forms a solid, okay? So, what we're looking for would be what is insoluble, okay? And normally, if it's not part of this rule, then it's going to be insoluble, and that's going to be your precipitate. Now, the rule that we've been waiting for is pretty easy, okay? It's Snape, okay? S-N-A-P-E. Now, S stands for sodium, okay? Sodium. N stands for nitrate. A stands for ammonia, which I'll just write here for you. Actually, I'll do this for all of them. Next one is potassium. And the last one that you're going to have is a very odd one, but if you see it, you're going to have ethanoates. Okay. And where you might have seen this ethanoate or ethanoic acid is in vinegar, where the molecule, I believe, is CH3COO-. That's the molecule, CH3COO-. So if you see any of these 5 molecules, right, it's going to be soluble in water, and it's going to form an aqueous. Forms an AQ, more often than not, okay? However, if you see a reaction, okay, and you have a look at your product, okay, and it's like, which one is gonna form a solid? So whatever it is, right? Dot dot dot, and it forms like sodium nitrate and lead iodide, okay? As an example, right? We can use this rule, Snape, to figure out which one is going to be our precipitate. So what we can see here is, let's look at NaNO3 first, okay? Sodium, okay, it contains sodium, yep, and it contains a nitrate, okay? So we're going to mark that with ticks, okay? So this one's a double tick. And now we're going to look at lead iodide, okay? Now, lead isn't sodium, nitrate, ammonia, potassium ethanoate, cool. So no tick. Iodine, is that in here? No, it's not. Okay. So what that means that is, because this is double ticked, right? And this is soluble, so that means like it's really gonna want to go into the water. NaNO3 is gonna be our aqueous, and lead iodide is gonna be our solid. And that process and this rule pretty much applies to anything, and it's really good just to refer to quickly in an exam if you need to save time for a solubility type question. However, I believe in the formula sheet that QCEGuy gives us, we have enough opportunity to go to the table, and there's a solubility table, so always check that over this rule. But for a general rule of thumb doing worksheets, and pretty much all of them, the Snape rule will work for everything, basically. And I hope that's enough in depth for you about how to convert worded equations to ionic equations and whatnot, and enjoy the rest of your morning, afternoon, or evening. Thank you.